Okay, the Chandler oil blending problem. That's only kind of a blending problem. Okay, this problem's been around since I was in the class. It's literally the same thing that was in my slides. My slides are like printed behind me. Um, when I was in the class in like 2007. So this like problem's been around for 20 years. It is a blending problem, not just because it says blending problem, but because we are taking ingredients and we're turning them into products that we're going to sell. And we're doing that in a way where we get to decide how much of each of those ingredients is going in to make the product. Before, when we were doing resource allocation problems, we were deciding how many things to make, right? We had kind of like ingredients. We had, but it was resources. It was like, okay, I've got 100 units of wood and 400 units of screws, but the important part is that it told us the recipe. It said, okay, if you want to make a chair, it takes 10 units of wood and 25 screws. I wasn't deciding how much wood and how many screws to put in to make a chair. That was given in the problem. But in a blending problem, I am deciding how much of each ingredient is going into the product. Now, this is a simplified blending problem because they're actually pretty long, and they want to be able to um, focus on some of the elements of it. So, just for kind of visual representation, right? In a blending problem, generally speaking, our decision variable is an xij variable. We're going to say let xij be the amount of ingredient I use to make product J. And then it's like however many ingredients you have and however many products you're making. Okay? And when we think about this visually, in this little abstract example, I have two ingredients. One, so these are my eyes. Two, and I'm using that to make products one, two, and three. And so every arrow is the same as like a transportation problem, is a variable, right? This first one is x1, 1. Then I've got x1, 2. And I've got x1, 3. And most importantly, the total amount of ingredient 1 is x11 plus x12 plus x13. The total amount of ingredient 2 is x21 plus x22 plus x23. Right? It's the amount of product 2 going into, or sorry, ingredient 2 going into product 1, product 2, product 3. Which also means that the total amount for each product is the sum of the ingredients. So how much of product 1 do we have? Well, it's how much of ingredient 1 did I put into product 1 and how much of ingredient 2 did I put into product 1, right? And you'll notice that because the J is what product it is, right? When I'm talking about product 1, the J's are both 1s. When I am talking about ingredient I, right, if I'm talking about ingredient 1, then that I spot is all 1s, right? So the amount of product 2 is the amount of ingredient 1 going into product 2 plus the amount of ingredient 2 going into product 2. Same thing for product 3. And if you have this visualization, right, you can see why this looks so similar to a transportation problem, then it can be quite helpful for the rest of the solution here. Okay. Now, in this question specifically, Just wanted to add another copy of it so we could work directly with it. Okay. We have that the gas sells for $25 a barrel, heating oil sells for $20 a barrel. So we're making gas, we're making heating oil, we're using crude oil 1, crude oil 2. Gas has add cost of 20 cents a barrel, heating has 10 cents a barrel. It's almost negligible in this problem, but it's still there. And we have this attribute. Gas needs an average quality of at least 8. Heating oil needs at least 6. And this attribute is what you're going to see me refer to as the blending constraint. Because without this, we are not going to have an interesting problem. If there was no constraint about this quality, or sometimes you'll see like iron content or like all kinds of random things, we would just use the cheapest product or the cheapest ingredient to make the most expensive product so that we have the highest margin. Okay. Here we've got 5,000 barrels of crude oil 1, 10,000 barrels of crude oil 2. Crude oil 1 has a quality of 10, crude oil 2 has a quality of 5, right? So we see there are these attributes that the ingredients have, and we have to have an average workout in the product. Demand is unlimited. How should we maximize profit? So we're going to start with our decision variables. We're going to say let Xij be the number of barrels of crude oil I used to make product J, where I is going to be, crude oil 1 or crude oil 2, and J is going to be G for gas and H for heating. I could have also just made it 1 and 2 there, but you'll see it can sometimes be a little bit helpful to have one as numbers, one as letters. And you don't have to draw this picture, but again, visualization sometimes super helpful. So I have my ingredients. I've got crude oil 1, I've got crude oil 2, and they are being used to make gas and heating oil. So remember, each one of these arrows, right? This is the amount of crude oil 1 going in to make gas. This is the amount of crude oil 1 going to make heating oil. For crude oil 2, right, I've got the amount of crude oil 2 going to make gas, and I have the amount of crude oil 2 going to make heating oil. And it's helpful to visualize the fact that the amount of gas that we're going to make is how much crude oil 1 goes into gas plus how much of crude oil 2 goes into gas. This is my total barrels of gas. For heating oil, right, how much of ingredient 1 goes into heating oil, how much of ingredient 2 goes into heating oil, and that tells me my total amount for heating oil. Same thing for crude oil 1, right? How much crude oil 1 am I going to be using? Well, the amount going into gas plus the amount I'm sending to heating. For crude oil 2, the amount going into gas and the amount going in to heating. And this is just helpful because now when we go to do our our objective function, we can use this to help us visualize for our profit, right? Here it has told us that our goal is to maximize profit. And so if we try to maximize profit, profit is revenue minus cost. But in this problem, we've got gas selling for $25 a barrel. and it has a cost of 20 cents per barrel. So when we go to sell gas, 25 minus 20 cents, we want to multiply it by how much gas am I going to sell? Well, how much gas am I going to sell? I've got my nifty little chart there. X1G plus X2G. Right? That's my margin on gas. And this is my amount of gas. For heating oil, same thing. So for heating oil, it sells for $20 a barrel and it has an ad cost of 10 cents per barrel. And my quantity of heating oil is the sum of its parts. Now, depending on the specifications of your professor, proper linear format, we want one coefficient with one variable. So it'd be like 24.8 x1g plus 24.8 x2g plus 19.9 x1h plus 19.9 x2h. Okay? But then we get into the far more interesting stuff. We get into our constraints. And before we actually go through and build them, I just want to identify the constraints. So we have the gas needing an average quality of at least 8. We have heating oil needing that average quality of 6. And then we have our maximum of crude oil 1 and crude oil 2. And then we're going to have non-negativity. This question is simplified down because it's a teaching example where we don't actually have costs associated with crude oil 1 and crude oil 2 specifically, right? And because we're trying to maximize profit, we are just going to use 5,000 barrels of crude oil 1 and we're going to use 10,000 barrels of crude oil 2. And there are ways to simplify this problem because of those assumptions. I'm going to show you how to solve this if we didn't have those simplifying assumptions because it works in every blending style problem, okay? So let's start with the supply constraints on the 5,000 barrels available of crude oil 1 and the 10,000 barrels available of crude oil 2. So for constraints, I am going to do that crude oil 1 supply. And what I'm trying to say with this constraint is the amount of crude oil 1 used has to be less than or equal to the amount available. Okay? This is the same as a resource allocation question, okay? What's our amount of crude oil 1 used? Well, it depends on how much went into gas and how much went into heating oil. So x1g plus x1h less than or equal to 5,000. You can, in this question, because we are maximizing profit, we are going to use all of this crude oil. You could also have this done as it equals to 5,000 and it would also be correct. When we are doing linear programming though, equals, like constraints that have equals on it are tougher on like solver to actually solve it. And so even though I know it's going to actually end up being 5,000, I would program this in as a less than or equal to 5,000 just so it doesn't over constrain the problem, but both would be right on an exam. Crude oil 2 supply. Again, we just want that amount that we're going to use has to be less than what's available. So the amount used less than or equal to what's available. And so the amount of crude oil 2 is what goes into gas and what goes into heating, and we have 10,000. And again, because of the way this problem is simplified, we are probably going to use all 10,000. Okay? Again, I don't like to over constrain it, so I would always go with the less than or equal to's. But then we get into the blending constraints. And we know that gas has to have this average quality of at least 8. There are several different ways to think about the blending constraint. Okay. So if when I explain this, it doesn't make exact perfect sense to you, you can like take a look at the videos that are like in the review session, um, because I do it a little bit differently in there. I'm just trying to give you a variety because there's lots of different ways that our brains work. So what we want to understand is that crude oil 1 and crude oil 2 that is going in to make our gas. Okay? Everything from crude oil 1 has an average of 10 quality. And everything from crude oil 2 has a quality of 5. The fact that we describe it as quality sometimes makes it a little bit tricky, but what I want you to see here is that, okay, we need to get an average of 8 out. So if we think about quality in, kind of quality out, and it doesn't have to be quality. It could be like grams of iron. It could be percentage of gold. It doesn't matter what the attribute is, okay? We want the total in to, in this case, be at least 8. So be greater than or equal to 8 times the quantity of gas because we want it to be an average of 8. And so if I wanted to create an average, right, that average would be, okay, well, what's that total quality in? And it would be, let me divide by my total amount of gas. And I need this to be at least 8. Except that we would have variables on the top for total in the total quality, and we'd have variables for the total amount of gas, and you cannot multiply or divide variables in linear programming, so we bring it up. And in my experience, it is better for us as commerce students to just think about it as the total amount going in has to be at least 8 for each of the products. So we're multiplying by that total number of products. So when we look at the total going in, right, there are 10 units of quality for each crude oil 1 going into gas. There are 5 units of quality for crude oil 2 going into gas. And I need this to be at least 8 for my total amount of gas. And my total amount of gas is the sum of the parts. Right, so I've got that total amount going in. So this is my quality for 1, and this is my amount of 1 going in. But it's the total quality going in has to be at least 8, but 8 for each barrel that we make, so we're multiplying by that total number of barrels. Now, in order to make this a proper linear equation, you can put this into Excel, just like this. Excel is smart. But depending on professor requirements, when you're writing it out, we want to bring all the variables to the left side, only numbers on the right-hand side. Yes, I literally had to go left and right there. And so when I rearrange this, right, I'm going to have 10x1g plus 5x2g. I'm just going to expand that 8. Actually, I'll just expand and bring it over. So I'm going to have negative x1g, negative 8x2g greater than or equal to 0. And so then when I collect like terms, I'm going to have 2 as the coefficient for 1g minus 3x2g has to be greater than or equal to 0. Now we're going to do the same thing for heating oil, which needs to be at least 6. So when you don't have to on your exams or anything like that draw out this picture, I'm just trying to help you wrap your head around the fact that I've got quality ratings of 10 and 5. The amount that goes into heating oil for crude oil 1 is 1H. The amount of crude oil 2 is 2H. And I need this to come out as a 6 over there, right? And we know, well, at least a 6. And we know that the total amount of H is the amount of 1 plus the amount of 2 combined. So what is my blending constraint? It's that this has to be at least this. So how do I set it up? 10x1h plus 5x2h has to be at least 6 times x1h plus x2h. For proper systems of linear equations, we're going to expand that 6 in and bring it over. So it's going to be this 10 minus, I'll just write it out. Why do I? Okay. So then I'm going to have 4x1h minus 1, so I can just leave it as x2h greater than or equal to 0. Okay. And this is my constraint. And then I need my non-negativity, where I'm just going to say, well, I mean, you can write them each out. They all have to be greater than 0. Remember, you can also just write xij greater than or equal to 0 for all ij. These mean the same thing. So that upside down A is for all. And there we go. Blending constraints. Hard, but like if you look at my picture and you're like, this bubble versus this bubble, it makes more sense for some of us. There you go.